Okay, so let's have a look at the answers to this. So first of all, I asked you to write a simple calculator that asks the user to input two numbers, then adds them together and displays the results to the user. So here I've just done that as I've got a variable called a, into which I'm storing the result of this input and this casting. So I've combined it into one line. You may have separated out, that's equally fine. But I've asked the user to input, please enter a first number, casting that as an integer. Done the same with variable b, and then I've stored in a variable called result the calculation a plus b. So now add a and b together and store that in a variable called result, and then I can just use the print statement to print out the value of result. So print the result is, and then result. Then for task 2, I want to check whether the output of that calculation is 1 million or more. Well, because I've stored it in a variable called result, I can just check the value of result. So here I've said if result is greater than or equal to 1 million, print, wow, that's a big calculation. Then for task 3, so we want to check whether something is a cube or cuboid. So I've got 3 variables, length, width, and height. And similar to the first task, I get the user to input each of these things. Again, we need them, in this case, as integers. You'd probably, if you were doing this in reality, cast them as floating point numbers, because they may well have decimal places. But for simplicity, I've just done integers here. And then here, once we've got the length, width, and height, I use an if statement to check whether they're all the same. Now, a couple of you ran into problems here. Because you were trying to say if length equals width equals height. You can't do that. You can only do one comparison operator at a time. However, we do know, for example, so if I check if length is the same as width, if that's true, then width and length must be the same. And therefore, I can check either of those against height. So if length and width are the same and one of those is the same as height, then they must all be the same. And so in which case, I will do this block of code here, saying this is a cube, and then I will calculate my volume by simply raising length to the power of 3. Otherwise, I will print this is a cuboid, and then I'll calculate the volume as length times the width times height. Now, of course, you could calculate volume in this way, and if you're doing this for real, you just do that anyway. I'm just getting you to do that as an artificial example to get you to try raising something to a power versus using the multiplication operator, and then print out the volume down here. So task 4 was the one that some people struggled with, and please don't worry, it even threw off a couple of Pencordians as they were trying to think through this. So don't feel too ashamed about that. It was designed to make you think a little differently. So what we can do, we essentially want a piece of code that asks the user to input a number from 1 to 365 and assumes day 1 is Monday. And then we want it to print out the day of week. Now, what we can do is we can use the modulus operator here, because what modulus will do, essentially what we're trying to do is we're trying to take the number between 1 and 365, and we want to convert it into a number that's only got 7 possible values, okay, between 0 and 6, essentially. So the way we do that, we can use the modulus operator. So imagine in the first week, if we were to say, if you input day 1, then 1 modulus 7, well, 7 goes, how many times does 7 go into 1? 0 times. 7 doesn't go into 1 at all, but you're left with a remainder of 1. So if it's 1, then it would be, if the remainder is 1, the output of that calculation is 1, then it would be Monday. If we had day 2, 2 modulus 7 would go, so 7 goes into 2 0 times, but we've got a remainder of 2, etc., etc. So that'll be Tuesday. And then, of course, when you get to day 7, then day 7, 7 modulus 7 is 0, because 7 goes into 7 exactly 1 time and there's no remainder. So then that would be Sunday. But of course, the beauty of using modulus is that then when you go to day 8, so 8 modulus 7, how many times does 7 go into 8? It goes into it once with a remainder of 1. So we're back to Monday, Tuesday, Wednesday, etc. So that it's a really useful feature to do that. And I see a couple of you were experimenting using dictionaries for this, which is would be the a great way to do this. I'm not going to penalise anybody that didn't, though, because you haven't been shown that much in dictionaries yet, so I didn't expect you to do that. So I was hoping most of you would have at least got to thinking about modulus, and if you manage to get to this, having a sort of if, elif, else statement here. And it's good. So hopefully all of these would work. You should never get to this else statement, but it's always worth putting this little else in here, because something must have gone very wrong if you've got down to here, because one of these things should always be true. So if that comes out, you know something's gone wrong in your code. Okay. Any questions about any of that before we move on? No? Fantastic. Okay, great. Thank you. Incidentally, if anybody that used the dictionary method, if you want to share your solution, please do. We encourage you to share your solutions publicly as well. Very free and open source.
Dan.
Hello.
Sorry, if I've got a query with my code, do I share it on the bread and butter pudding, or do I share it on the main site somewhere?
So initially you share it in bread and butter pudding in your peer support group, and then see if any of your peers can help. And if they can't, then somebody would then post on the support hub. But if you want to share something more widely, like, oh, I did it like this, and I want to share this with the whole group, then post it on one of the public channels, like the support hub or the plaza or wherever you like, to say, you know, I want to share this thing. This might be useful for people.
Okay, thank you.
So another thing we talked about in Thursday session was the idea of loops. We said that very often in programming, you're going to want to do the same thing a number of times. And it might be that we need to do the same thing for a given number of iterations, or it might be that we need to keep doing something whilst a certain condition is true. We looked at different examples. We looked at one which was, add 2 spoonfuls of tea, and that we can represent that as a for loop, or it might be to continue singing to me until I fall asleep. That would be an example of a while loop. So let's have a look at how we would do this in Python. So let's start with a for loop. So let's imagine we've got a for loop, and we want this for loop to count from 0 up to, but not including 10. If you're wondering why it's 0, Python, as with most programming languages, starts counting at 0. That's a very important thing that you need to get used to. And for the vast majority of cases, when you specify a range, it will go up to, but not including the number you specify. So if you say go up to 10, it'll say, okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, there are a few exceptions to that we will flag up when you encounter them. But generally speaking, you start from 0. The computer starts counting from 0, and it will go up to, but not including the limit number. Okay, so let's say we want to count from 0 up to, but not including 10. And we want to create a loop that does that. Then essentially what we want to do is to say, what number am I up to now? What is X? I'll call X the number I'm up to at the moment. So I'm going to start at 0. So X starts off at being 0. 0 is less than 10. So I want to print that number. And then I want to increment X by 1. I want to increase the value of X by 1. And I'm going to ask the question again, what's X up to now? What is up to 1? Still less than 10. Print the number, and then increase it by 1 again. And we keep going round this loop until we get to the value of 10. Once we get to the value of 10, we stop. We don't print out 10. We stop at that point. So the way in which we do this in Python is using this structure here. We use the for loop. We say for X, in this example, in range 10. So range 10 simply means give me the range of numbers from 0 up to, but not including 10. So the numbers 0 through to 9. So for each X value within that range, here all I'm doing is printing the value of X. So here I just say print X, and that'll print out on the display like this. Now, it might be that you want a custom range. You may not want to count from 0 up to, but not including 10. You may want to count, for example, from 10 up to, but not including 20. So that will give you the numbers 10 to 19. And the way we do that in a for loop in Python is rather than just specifying one input to the range, we specify two. So the first value is the number you want to start counting from, and that is included. And then the second value is the value you want to stop counting at, and that is not included. So it's up to, but not included, remember. So range for x in range 10, 20, print x will count everything starting at 10, up to, but not including the value of 20. It may also be, if you're doing a custom range, you also want to do a custom increment. We may not want to increment by 1 each time. So it may be that we want to count from the number 2 up to, but not including the number 30, but we want it to go up by 2 each time. And again, we can do that simply in Python. In our range, we'd simply specify a third parameter. So the first one would represent the number we're starting from. The second one, the number we're going up to, but not including. And then the third one is the value of the increment. So by default, that's 1. And if you don't specify anything, it'll increment by 1. However, if we specify a number there, then it will use that as the increment. So here, it'll start at the value 2. And then each time it goes around the loop, it'll increment x by 2. So the second value will be 4, 6, 8, etc., etc. You can also do the same, in case you're wondering, in reverse. So you can have a negative increment or a decrement. And to do that, again, we use the 3 parameter values. We have the starting value. We have the end value, which again is up to but not including. And then we have we specify the increment. But if we specify a negative number, it'll say decrease by that number each time. So here I've put -1. So it'll, in this example, start at the number 10, and it'll count down 1 each time until it gets down to, but not including 0. Now, you'll very often use lists in, for loops in that way. But another common thing that you may want to do is to iterate through a list. So it may be, for example, that you have a list called my list. It's got the values 110 down through HSMA. And what we want to do is to say, we want to do something to each element in that list. So rather than specify a range, what we can do is to say for, and then I've called it element, but it can be anything. You can call this anything you like. It's essentially a temporary variable. I've called it element. So for element in my list, that basically says for each item within that list. And then we can refer to element, which now represents that item. So it'll go first to the first item in the list. So here, we're just telling it to print the element in each iteration. So here, print element will print the number 1. And the next time around the for loop, it'll move to the next element. So now it's going to print that element. So it'll be the number 10, then the string Dan, then the Boolean value true, and then the string HSMA. Okay, so that's really useful when you want to see, not so much for printing, this is just a demo, but particularly when you get into looking at various more complex objects stored in the list, you can do something to each of those elements within a list using a for loop. So rather than going through as a count, you're going through the elements of the list themselves. So it's iterating through the list itself rather than a number up to a certain range. So that's for loops. We've also, say, got while loops, and while loops are also really useful as well. So let's imagine that we want to write a program, and why wouldn't we, that said, ask the user to type yes if Dan is the best, and it kept asking the user to do that until they typed yes. Now, obviously, this is a very good program that you should all write. So let's think about what we want the loop to do. What we're essentially doing, we first of all need to default to the user being incorrect, because that's the thing that's going to enter us and keep us in our while loop. So whilst the user is incorrect, we want to first of all ask if the user is correct. Well, they're not, because we've already started them as incorrect. So no. Then we're going to ask the user if Dan is the best. Then we're going to check what the user's answer is. If it's yes, then we can say correct answer. we record that the user is correct, and then when we go back around the loop, is the user correct? Now resolves to yes, so we can stop. But if they put anything else other than yes, then we'll print them the message, think hard and try again. Go back around the loop. Is the user correct? No, because we haven't updated the user's correct. So we're going to keep going around this loop until the user inputs yes to get them out of the loop. So here, let's look at the Python code. So here I've got a variable that I've called correct, a Boolean variable that stores the value false. And then here I say while correct is strictly equal to false, which is going to be right from the off. Then I'm going to get an input from the user, type yes if Dan is the best. I'm going to store that in a variable called answer. And then I'm going to do use an if statement to check what their response was. So if the value stored in answer is yes, then I will print the correct answer. And then I will set correct to true. And by setting to correct to true, when it now goes back around that loop, correct is no longer false. So that loop, you will then exit that loop. It will not go around again. However, if they didn't answer yes, they put anything else other than yes in block capitals, because they feel that strongly, then it will print think hard and try again. And correct is still false, so it'll keep going around that loop. So here, we can see that in action. We type, user type no, think hard and try again. I think this might be Mike. It's Mike, no, think hard and try again. He's got better t-shirts, he has, to be fair. And we keep doing that until the user specifies yes. Now, sometimes we want to break out of a loop mid-flow, whether it's a for loop or a while loop. So for example, we may have a for loop and we want to break out of it once a certain condition has been met. We don't actually want to go to the end if something happens. And we can do that using the break command. What the break command does is it immediately breaks us out of the loop and continues as though the for loop had completed. So it then continues for the rest of the code as though you'd gone through all iterations of the for loop. So here's an example. Let's say we've got a variable called total. I've assigned a value of 0. Then I specify a for loop that says for x in range 10, so for x values from 0 up to but not including 10. I want you to calculate the total. So we've already got a total value. We started at 0. So I want to overwrite that variable value with total plus x. So whatever value is in x, add that to the total, then print the total. And then if that total is greater than 5, I want you to break. So stop doing what you're doing. So the first time around, total is 0 and x is 0 as we go into the loop. So the first time round, total will be total, which is 0, will be total plus 0. So 0 plus 0 is 0. So the print 0 is the total greater than 5. No, it's not. Back around again. This time x is now 1. So x is now 1. Total, which is currently 0, equals total, which is currently 0, plus x, which is now 1. So 0 plus 1 is 1. Print 1. If it's greater than 5, which is not, then break. So we're going to go around again. This time, we've got a total of value 1, and x is now 2. So 2 plus 1 is 3. So total is now 3. Still not greater than 5, though. So round again. X is now 3. So for x in range 10, we've gone round. X is now updated to 3. Total is now 3. So 3 plus 3 is now 6. We print out total. Print out the value 6, but now this condition is true. So if total, we said if total gets greater than 5, then break. So the loop then stops as though it had completed. It doesn't go counting up the rest of the x values up to the value of 9. Another thing to be mindful of, and this will happen, I can guarantee it, is you can accidentally write an infinite loop. That is one that will never end. And anybody that remembers the good old days when they used to be programming in BASIC will remember a really good example, which you probably all did if you were programming back then, of printing an infinite loop. Where we would, in BASIC, we'd print something like 10 print hello world, 20 go to 10. Which in BASIC simply means do this instruction, and then in the second instruction, go back and do that again. That's an example of an infinite loop. You're going to keep doing that forever and ever and ever. So a more modern example could include setting up a while loop that can never stop. So let's imagine we've got a variable called x, and we set that to a value of 3, and we set up a while loop that says whilst x is greater than or equal to 3, then print the value of x, and then increment x by 1. Well, that means that while loop will never stop, because the first time around it'll be 3, and then the next time around it'll be 4, and then 5, and then 6. It's never going to end. It's never going to be less than 3, and therefore you've got an infinite loop. Or you might put while true, print Dan is the best. Well, there's nothing that will change anything because we use while true. While true is simply a shortcut way of saying do this forever, because true, you're essentially saying while true is true, which it'll always be true. That's a fundamental principle. Then keep on doing this forevermore. So sometimes you want to create an infinite loop. And you might use a while true statement if you want to deliberately create an infinite loop like this. For example, you may want to create a simple menu system that you want the user to keep selecting options from the menu. So you put all of that in a block of code until they select an exit option, for example, at which point we could use a break command to break from the infinite loop. If this does happen to you inadvertently and you don't want to be in the infinite loop, you didn't mean to create it, don't worry. If you run into that, or if you want to stop the program running mid-flow for any other reason, we had somebody in the exercise who accidentally done a very large calculation that was causing a lot of time to try and compute. Don't worry, just go into your IPython console, so where your outputs are, make sure that's clicked, and then hit Control and C, and that will break the program. It'll stop the program in its tracks. It'll stop it running wherever it is. Okay, so very handy to just bear that in mind. Control and C, if you get stuck in an infinite loop, or you want to stop the program for any other reason, very handy little tip. Okay, so I've stopped talking there. So in this latest lecture, you've learned about for loops, you've learned about while loops, and you've learned about how you break from loops. So what I want you to do now, again, switch back to Jupyter Lab. If I know some of you are having issues, I think there may be browser issues, browser security issues, which obviously we can't do much about. Don't worry, you can do all of this in Spider. I will post, as I did for the first exercise, I will post the questions in the Module 3 channel on Slack, so you can do these questions in Spider. That's not a problem. But for those of you who can, go into Python Prog Workbook 2 and spend the next half an hour going through these bits. Remember, you can test if your code is working by hitting Control Enter or by pushing the play button. So let's just have a look at those tasks. Oh no, that's the solutions. I hope you didn't see too much of that. Right. So Python Programming Workbook 2. So the first task, I want you to write a piece of code that asks the user to input a number, and then the machine prints out the times table from 1 times up to and including 12 times whatever number the user has input. So you want the code to print something like, if the user puts in 3, get your code to say print out 1 times 3 is 3, 2 times 3 is 6, etc. Up to and including 12. I emphasize that word, including. And then for the second task, I want you to write a piece of code that sets up a new list called pencord_team with initial values Dan, Mike, Tom, Sean, Kerry, Andy, Alison, Martin, and Sarah. And it iterates through that list, saying hello to each team member. Then for task 3, I want you to write a piece of code that asks the user to input a number, and we'll keep asking the user to input a number until the number that they enter is more than 100. However, if the user enters 0, then the program will exit with an appropriate message. And then for task 4, again, a little bit more challenging, so think carefully how you would do this. Write a piece of code that counts up day numbers from 2 to 364 inclusive. So you need to include day 364, and displays a message giving the day number every second day and additionally displays a reminder to go shopping every 4 days. Okay, so have a go at those. I'll copy and paste the questions for those of you using Spider into the Module 3 channel. Have a go. You've got half an hour. We'll come back just after 10 past 12. Again, if you get stuck, ask your peer support group. And then if you're really stuck and nobody can help, then post a message in the hub. And we as mentors will be floating around, keeping an eye on things as well. Okay, any questions about any of that? Okay, great, fantastic. See you in half an hour.